Hi, in this video we'll look at how to implement a transparent data encryption in a multi-tenant Oracle database environment. So before we go into the actual demo, let's go through the brief overview of the transparent data encryption and what's the architecture of the transparent data encryption, and as well as what's the problem that we are trying to solve, and how the transparent data encryption interacts with the multi-tenant database environment. So if you look at the Oracle transparent data encryption, it supports two different ways to encrypt your data at rest. So first is at the table space level, where in all the tables that are stored in this table spaces will be encrypted when you implement at the table space level. And another one is the table level. So all the you can select particular columns in your table that you would like to encrypt, and this encryption process is done transparently, so the application doesn't have to have any understanding of the encryption, and it protects your data at the rest. So if you look at the architecture, so here you have a database that supports table space encryption and the table level encryption, and you have different components that you need to set up before even you start the TDE. And for that, first you need to take a look at your environment, and based upon your requirements, you may configure the encryption, KEYSTORE and wallet based on your requirements. So if you look at the TDE from a very high level, you have your wallet, that's where the keys are stored for the encryption, and you have your database where the data that needs to be encrypted. So the wallet can be stored in a or can be integrated with a HSM, the hardware secure module, or it could also be interfaced with a software protected. It could also be a software protected wallet. So within the software protected wallet, there are three different kinds. One is a normal wallet, another one is the auto login, another one is the local auto login. So the difference between these three wallets is that auto login will normally, when the database starts, the wallet will automatically opened by the database, and so the encryption, either the encryption or the decryption, can happen right away. The local auto login is a little bit more secure than auto login, where the wallet that is created on a particular database server is local to that. That means you cannot use that wallet to open the same database, backup of a database on a different Oracle database server. So it has to be, so that's the limitation of the wallet, that's being the difference between the auto login versus local auto login. A lot of the companies use auto login because it's pretty easy to use, but one disadvantage, which is that one person is or the idea of the split knowledge base for a security mechanism. For example, if you don't use auto login, you would like to have the key stored in a different team, and the database is being managed by the DBA team. So both teams none of the teams have the information in order to decrypt the data or to be able to use the database backup in another environment. So that'll give you some additional protection for the encryption that we will be implementing. So inside the wallet, you have keys. The keys which are at the database level. These are called database master key. So the database master key could be generated from could be an asymmetric. The encryption could be asymmetric or symmetric. If you need to have an asymmetric encryption, then you need to use a certificate. That's where the key is derived from. If you don't care about the encryption process, and if you want to use a symmetric encryption, then the key is generated internally. And so there is a key at the table space level or at the table level based on the type of encryption you're doing. So these both keys, depending upon asymmetric or symmetric, forms a key pair in order to decrypt or encrypt your data. So the example problem that we will be looking at, we have a Oracle 12c, container database. We have a CDB and we have a PDB. And in our case, we want to encrypt a table space at a PDB level. And how do we address this? So the solution in this scenario could be we set up a wallet. In this case, let's go with the auto login, and it's a software protected, obviously. So you will be securing the wallet with a password. And auto login will allow the database to automatically open or close the wallet whenever it's shutting it down, or it's being restarted, or in different scenarios where there is no human intervention for the database to start and stop. So and there needs to be it's the requirement from Oracle that there needs to be a database master key at the CDB level, and there needs to be a database master key at the PDB level, and this database master key at the PDB level will be used in conjunction with the a key at the table space level to do the encryption or the decryption for our table space. So in this scenario, we need to set up a wallet, an auto login wallet. For the auto login wallet, one requirement is that first you need to set up the key store with a password based key store in order to create an auto login key store. So we'll do that first, and then create the auto login key store in a wallet, and then we'll set up the database master key for the CDB level, and then we'll set up the database master key at the PDB level, and then we'll start the encryption process. So hopefully this gave you an overview of what we are going to accomplish in this demo. So let's log into our virtual machine here and start the process. So one of the things that I did not mention in my in the introduction is that the setting up, how you're going to set up the wallet. So in our case, we are going to set up the wallet in a particular directory that Oracle database can read. So that directory could be anywhere. It could be locally on the machine, or it could be a network share, as long as the Oracle service account has access to that wallet. So in our case, we will be setting up the wallet in our local database, local directory. So the first thing, the way the Oracle database knows the location of the wallet is using by setting up a wallet parameter in the sqlnet.ora. So let's go ahead and do that. So in our case, so this is the wallet encryption wallet location. So we are going to copy this. I have all the commands that we are going to do today in a notepad, so we'll be using these commands as we walk through the demo. So first thing we'll do is we'll set up the wallet location. So in this case, let's go here and go to the Oracle database directory, and the TNS admin, network admin location. So we go to the admin, go to this, modify the sqlnet or open with a simple text pad, and we'll copy this wallet location here, and that's where the wallet will be created, and it will be storing the key stores. It will be storing the key stores and the database master keys. So let's save the sqlnet.ora file, and let's make sure this directory is valid. So let's go back here into admin, and let's create a folder, and inside that let's create the folder for database instance. So in this case, if you have multiple instances on a particular server, then you would like to keep these folders separately. So that's why it's probably the best practice to start doing that when you first build for a particular instance on a particular server. So in this case, we had set up the wallet location. Now let's log into the database. So for the database steps in the database, we will be opening two command sessions, one for the CDB and one for the PDB. All the operations that we need to be at CDB level will be typing it in the CDB command window, and all the operations that we need to do in the PDB will be typing it in the PDB command session. So let's open the command. And let's also open another command. Okay, so let's log into our PDB and CDB. So this is my CDB instance, so I'm going to connect to here, and then this is my PDB instance, so I'm going to connect to here. Let's see what's happening here. So it's unable to probably find the TNS entry. So let me let me go back here. So I don't have a TNS entry for my PDB, so let me do that here. orcl PDB. Yep. So orcl PDB. So I'm gonna save the TNS names. I just did not had an entry for my PDB in the TNS names file, so it's unable to. Okay, so that's great. So we are in the so we are in the database right now. So let me actually go back and actually show you. So right now this directory is empty. So the first step, if you remember, first thing we need to do is we need to set up the wallet. So so the wallet is set up initially by creating a key store. I mean, key store literally means a wallet. In terms of the way the terminology is being used here, so just so you understand. So the first thing we are going to do is we are going to create a software based key store which is protected by a password. So let's go ahead and do that. So you can see here it creates a PKCS based certificate, I mean key store, that's probably it will, and that will be managed by the Oracle from going forward. So we had created a password based key store. So the administer key management is an API provided by Oracle to manage the key stores and wallet. So if you look at the command, we are just providing the command create key store and the location of the key store and identified by the password for the key store. So we did that. Now the next thing we are going to do is we are going to create an auto login key store. So and the command here is the same as well as the previous one, but basically we just add auto login, and so we create a second key store, and this key store uses the key store key from the original key store that we created here. So so in this one, when this runs, it creates an SSO file, wallet file. These both are important in order for the key management to properly work. So just make sure that you don't delete or modify any of these outside of the key management API provided by Oracle. Now there are certain additional operations we need to do that I think I did not discuss in my initial introduction, is that we need to open the key store. So opening and closing is an important operation that's normally done by the Oracle internally whenever it starts and stops the database. But in our situation, we are creating the keys for the first time, so we need to make sure we open the key store, we create the key, and then and then we can start our encryption process. Now this is the next steps that I'm going to show you are you do this only when you actually set the keys for a particular database. So you don't have to do every time you want to encrypt a table space. So now let's open the key store in the root container. Okay, now let's set the key store, set a key for the root container database. So we just type the administer key management and set key and identified by the password with backup. This is important. If you don't include with backup, it will fail. Okay, so you can see here it automatically creates a backup of the the wallet here, and all the key stores in that wallet, and then it can so that we can use it to restore in terms of in case if you have any other operations that are still pending in your old wallet or key store. So now what we do is we finished all the operations that we need to do at the CDB level. Now we are going to go with the now we are going to look into the PDB level. So So the PDB level, we are going to, the only thing that is left is we are going to open the key store, and then we are going to set the database master key at the PDB level. So to open the key store, you run this command. You can see I'm at the PDB level. Now we actually set the database master key for the PDB database. Okay, so that now that's done. So as you can as you probably might see, there will be multiple backups, because anytime we set the key, we are taking the backup. So now so we had set up everything we need, the wallet, the key store, the keys, all everything we need in order to start the encryption. So our encryption will be done in a table space of a particular PDB. So we are going to create, in order to show the demo, we are going to create two table spaces, one encrypted, one and non-encrypted. So let's create the encrypted table space. And for the encrypted table space, you can see the all the options are pretty straightforward, except this keyword. You say encryption using AES 256. So that's the algorithm we are using to encrypt this table space. So let's go ahead. So whenever you create a table space or alter a table space, the key is not automatically generated for the table space. So as I do this, I know the key is being generated for the table space as well. It's probably stored in the header of the table space or within the system views. We are not sure where that is, and probably Oracle will never let us know where it is. So let's create another table space. In this case, this is an unencrypted table space. So I'll show you why I created two table spaces. So here encrypted and unencrypted. Unencrypted does not have the option of encryption in either. So let's create two tables, and one in the encrypted table space, another one in the unencrypted table space, just to show you how it will help us to encrypt the data at rest, so that you don't have to worry if the backups or the disks are being stolen, or so that nobody will be able to make any sense of the data. So here I created two tables here, test encrypt, test unencrypt, and then in these two table spaces, and I inserted one record in these tables called this is a secret. So let's commit this transaction, and let's also force a checkpoint so that the data gets flushed into the data files. Okay, so let's close this session, and now let's look at the table spaces itself, see how the data encryption is actually happening, or this is where the actual benefit of doing this. So if you look at the unencrypted table space and probably open with a simple text editor, you can also actually open with an hex editor, probably make more sense out of it, but in our case, probably text editor should be sufficient. So if I type this is a secret, I found this data in the plain text in our table space file, so which is not good. This is the case for the unencrypted table space. But if I search the same word in our encrypted table space, go back here and search, this is a secret. No, you can't find, because it's actually being encrypted. So that's kind of sums up our demo here. Hopefully you have a good understanding of how TDE can be implemented in a container Oracle container database environment. So let me actually provide a brief summary of what actually we implemented. So first thing we did is we had set up a wallet, which we created it as a software protected with a password, and it's an auto login wallet. The next thing we did, we created a database master key at the CDB level, and we had to open the key store because we are setting the key for the first time. Since it's an auto login wallet, you don't have to do that, but anytime you are creating a database or creating an additional PDB or setting up a key, you need to open the wallet. So here we are also assigning a database master key for the actual PDB instance where the table space will be being encrypted. So at a high level, these are all the different steps. There are different kind of scenarios and different things that you can do that we will be looking in the videos coming ahead, but this will should provide you a very good idea of how TDE can be implemented in a multi-tenant environment.